Chris Johansson.
And I'm Taylor Dark. Our project was creating a web server and managed wireless speakers.
Last summer, I was trying to come up with an interesting and useful proposal for my senior design project. This project combines a hobby of mine with an engineering interest of mine. I like to listen to music whenever I'm doing just about anything, and I think that computer networking is one of the more exciting fields in computer engineering. As I formed my idea, I talked with my friend Taylor about it to see if she thought it would be a good idea and if it would be a project she'd be interested in working on.
The idea was to take a $35 computer called a Raspberry Pi and use it as a server to control a number of microcontroller systems, which we referred to as satellite units. The satellites would have a memory chip, an audio output system, and a Wi-Fi module to allow the satellite to communicate with the server. The plan was for the server to provide a web page to its local area network. That web page would effectively be the interface for a media player, but instead of playing music from the speakers on the computer the user is sitting at, the music could be played from any of the satellites, which would have a variety of audio output jacks, which could be used such as 3.5mm RCA and speaker wire.
As fall term started, we picked up a third group member and began fleshing out the details of how exactly the system would be built, as well as what design requirements we would try and meet. Here's what we came up with.
Our first requirement is that the time between selecting a track on the server and a satellite playing the track must not exceed 10 seconds if the media has not been buffered on the satellite. The goal of this requirement was to make the experience of using the interface as similar to using a typical media player as possible. We chose 10 seconds as our requirement to allow for some amount of uncertainty in the file size and channel noise while still ensuring feedback to the user in a reasonable amount of time. Our second requirement was that the server must be able to mount 5 different network shares as additional media sources. We chose to focus on public network shares to avoid any unnecessary hassles with security and storing of credentials. This suited our needs because the network shares would almost certainly be just on the local area network. The goal for this requirement was to expand the amount of storage that could be used for music from the 12 gigabytes we could fit on the SD card in the server to as large as any user could want by allowing access to much larger hard drives in other computers. Our third system requirement was that the satellites and server must have 0 visible solder joints when enclosed by their cases. We chose this requirement because we wanted to make sure that when we finished our project, it could sit on a shelf or a table or be shoved under a couch without worrying about what might happen to it. We wanted to use our project around the house and not be constrained to static-free and electrically safe environments. Our fourth requirement was that within 1 minute of being powered on, the satellites should connect to the wireless network and send a packet to the server process indicating that the speaker is ready to be used. Our server had no automatic way of knowing how many satellites were connected or at what IP addresses they could be found. To solve this, we had the satellites contact the server after they have been powered on and initialized. We chose a limit of 1 minute to ensure that the user is not left waiting and waiting for the system to come online. Our final satellites are able to contact the server in roughly 40 seconds, informing it that they are ready to be used. Our fifth requirement is that up to 20 speakers must be able to be connected to the server simultaneously. The goal of this requirement is to ensure that our system would support enough satellites to fill a large house with many rooms. Building 20 satellites was certainly not in our budget, so we designed a series of tests to do our best to ensure that the user interface, network, and server back-end were all capable of handling the volume of data needed to serve 20 satellites. The sixth system requirement was that all functions of the web interface accessible when using a desktop browser must also function when the page is loaded on Safari on an iPhone and Chrome on an Android without installing additional plugins. The goal behind this requirement was to make the system as broadly compatible as possible. Even if we had the resources, we believe that developing special apps for Androids or iPhones are less preferable to a unified web interface. This is because the web interface allows access from essentially any device with a browser without worrying about hardware. However, if time had permitted, we would have created a separate mobile web interface to improve ease of use on devices with smaller screens. Our seventh requirement dictated that the web interface will allow the creation of 5 user accounts and the assignment of permissions limiting which speakers a user can use. We chose this requirement to complement our previous goal of supporting many devices. This seventh requirement allows us to better support multiple users. By allowing the assignment of permissions to different users, an administrator can dictate who can issue commands to different satellites. For example, the administrator could reserve living room speakers for the parents of a household, while allowing their children only access to the satellites in their respective rooms. The eighth requirement we chose states that the system must be capable of playing 256 kilobit per second MP3 files. The goal here was to ensure that our satellites could reproduce sound of a high enough quality that it would be pleasing to most users should they choose to play it at a reasonably high volume. We did not opt to explicitly support lossless codecs, as we fear this might tax the capabilities of the system, and they provided an improvement many would call inaudible over audio with a 256 kilobit per second rate. The ninth requirement was that the users must be able to save a new playlist to the server or load an existing playlist from the server in under 0.5 seconds. This requirement was not particularly well worded, but the idea was that the server would not take more than half of a second to process a request to save or load a playlist. The goal behind choosing this requirement was to provide a useful functionality and to ensure that the performance of the interface was similar to the interface of a typical media player. Our final requirement, and the only requirement we were unable to achieve, was that 2 satellites playing the same track must start within 100 milliseconds of each other. The goal was to allow multiple satellites to be linked together such that when one was instructed to play a song, all linked satellites would play that song. This proved to be a difficult requirement as the limits of process scheduling precision and the ability of the human ear to distinguish out-of-sync playback combined to make this requirement impossible. Due to the method we chose to play media from the satellites, an unpredictable lag was incurred depending on a multitude of factors which could span up to half a second, 5 times what was needed to meet our requirement. This would occur after any attempt to synchronize the play song instruction. Some circumstances beyond our control led to this problem. However, if we were taking this course again, we would be more wary of creating hard limits on timings, as subtle changes in code or state of a processor can often have large implications when attempting to time an event very precisely.
During winter term, our third group member was forced to withdraw from the course. This left us scrambling to make adjustments to the design in order to ensure that we would be able to have a somewhat finished product by the end of the year. Instead of building the satellites from scratch, we elected to use Raspberry Pis for the satellite as well as the server, which freed up time that would have had to be invested in PCB design and microcontroller programming. This replacement led to most of the hardware in our project being off-the-shelf components. So to retain some custom hardware in the design, we agreed to build an audio amplification stage, which would output the audio on the speaker wire, and in addition, we still had to come up with a solution to power the satellite and amplifier. So, without further ado, here's a demonstration of our completed project. When you first load the Danger Zone webpage, you'll see several sections. There's an area for speakers or satellites in the upper left, playback controls in the upper middle, and a login area in the upper right. Below the speaker section, there is an area for adding and selecting audio sources or music servers. Filling the bottom portion of the screen are 2 panels that will display lists of songs. The first thing you'll probably want to do is press the login button and log in as administrator. After you've done this, you can see a message on the screen indicating that you're logged in. If there are any connected satellites on the system, they should be displayed in the upper left region. From here, you will want to create a user account by pressing the Create User Account button. Enter a username and password. Select a few satellites that you want. Say I want 1 and 4. And click OK. This will create an account giving the user permission to use the satellites administrator has selected. So we have successfully created account user. Now log out as administrator and log back in as the new user you've created. You should see a message indicating that you're logged in as the new user, and in the upper left area you should see the satellites that you selected, 1 and 4. From here you'll probably want to build a playlist. Notice the list of songs in the left panel. These are the songs in the default music server local. You can use this server or add new ones. If you want to add a new one, click Add Server, pick a name, and a path, and your platform. You can either hit submit or cancel if you change your mind. Bob is added to the list. But right now, we're going to look at local, in which the list of songs are appearing in the left-hand side. Now you're ready to build your playlist. Say I want a playlist of only one band. Go through, select the songs I want, then click Add to Playlist. All the songs I selected move into the right-hand panel. Now you can select one or more satellites and click on the play button. Your new playlist should start playing. Just play. There's forward. Back. And stop. Playlists can also be saved more permanently. Notice the Save Playlist button is now active. It wasn't active when there was no playlist on the right. If you click Save Playlist, you will get a pop-up that lists any currently saved playlists, and a text box to enter the name you want to save the playlist under. You can type a new name to save under or click on an existing playlist if you want to overwrite it. So, save. Now if you click Clear Playlist, your current playlist will be removed from the right panel. If you click Load Playlist, you get a pop-up with a list of currently saved playlists. Select any of them and click Load, and your playlist will be loaded into the right panel. So this is the one I just created. Load it, and there are our songs. You can also remove songs from the current playlist by selecting them and clicking Remove from Playlist.
In conclusion, we've been asked to provide recommendations for future senior design groups based on our experience. First, we'd recommend that you get started early and try and come up with your own project idea. Not only will this let you start researching and planning your project early, but it also means you're more likely to end up on a project that you're passionate about. We have both wanted to get our project working all year, and it's been very exciting seeing things come together. Even if we do have 100 more features we'd like to eventually add to the system, the level of dedication required to see a project through 8 months of what can be very frustrating work is much harder to achieve on a project you don't really want to bring to life.
Second, we'd like to say we all have imagination. That's why we're engineers. We can come up with all sorts of wild and awesome solutions to problems that some people might not even see. But just because we can see a solution doesn't mean we can build it in 8 months. 8 months sounds like a lot of time, but keep in mind senior year classes don't take any less time than junior level classes. And now you have senior design on top of that. Know your limits and don't promise more than you can deliver. When you're designing your requirements, pick requirements that ensure basic functionality of the system and save the "it would have been neat if we could have also" types of ideas for if you have extra time at the end of winter term.
Our last advice is to make sure you're always in touch with your teammates. Senior design projects are meant to be done in groups, so you should take advantage of that. It may be tempting to stay home and not go to campus to meet with your group, but more communication between members will make your project go much smoother. Even if your meeting is only to catch each other up on what each member has done in the past week, it's definitely worth meeting to remind everyone where in your project you are and what you have left to do.
Completing this project was a lot of work, but we had fun and learned so much. We'd like to thank Dawn and the TAs for the help and guidance they gave all year.
Thanks for watching our presentation, and remember to rock on.
Highway